This is All Things Ansys, a podcast from the technical support staff at PADT, episode 79. We are joined by Brent Stucker from Ansys Inc. to discuss all the great things going on with Ansys Additive suite of products, which is used for simulating 3D printing, along with news and events. Welcome to 2021. I'm Eric Miller, one of the owners of PADT, and welcome to this year's first podcast of All Things Ansys. I'm recording this on January 8th, 2021 has been about as sucky so far as most of 2020. So after this, we're talking about this today, how this has not been a good start to the year. With a few people at PADT, we concluded that the bad 2020 didn't really start till around April. So we expect the full calendar year of 2020 it's not a calendar year, right? So it won't be done with its nastiness till maybe April. So let's hope that things get better very quickly. Speaking of which, COVID has hit both my family and our PADT family. Not bad. For home, it's not been bad at all. My 18-year-old had mild symptoms, and I've been sick. You can hear it a little bit in my voice, but I haven't really had it bad, and I haven't tested positive as well, but I haven't been anywhere, and he has it, so I figure that's what it is. You probably read in the news that Arizona has widespread virus, and even if you're super safe, it's almost impossible if you leave your house to avoid. So our employees, unfortunately and very sadly, have lost family members, and a few have been sick themselves so far. Even though it's been pretty bad for some, they've all come through it okay, and no lasting impact so far. So, our heart goes out to everybody dealing with this virus. It's been at arm's length really for most of this pandemic, but it's getting closer and closer. And hopefully we get the vaccine soon. So let's all hope for that. And I hope all of you listening have been able to deal with this in a positive way. A bit about the podcast. I looked at the numbers for last year, and we're slightly up, but averaging about 600 downloads a month. So I want to thank everybody for subscribing and sharing the podcast. Please keep it up. Let other people know about it. We have a great slate of episodes planned in the coming months and throughout the year. So we look forward to talking about Ansys with you. And speaking of which, we're starting the year with a great interview. Brent Stucker is one of the co-founders of a company called 3D Sim. That's the 3D printing simulation software company that Ansys acquired about 3 years ago. He's been the project manager for the additive line for some time now, and recently moved over to really be the senior technical role for the additive product suite. It was nice of him enough for him to join us today and talk about the history of Ansys Additive, where it is today, and where it's headed. So it's really good stuff. Please take a listen. I want to welcome everybody to our discussion today on Ansys Additive, and we're very lucky to have Brent Stucker here on the phone with us, who has a lot of different responsibilities around the additive product line. I'll let him explain what that is. Brent, why don't you introduce yourself and what your role is right now at Ansys?
All right, thank you. Yeah, my name is Brent Stucker, and I've been with Ansys for just over 3 years ago when they acquired our company 3D Sim. And for most of the past 3 years, I was the Director of Additive Manufacturing within Ansys. So I had supervisory and planning responsibility for the additive product line. More recently, I've shifted to a distinguished engineer role where I no longer manage the product development, but instead interact primarily with our partners and customers to help them get the most out of our software, as well as just help them understand how to best create a good strategy for additive manufacturing within their company.
Very cool. Very cool. So I think a good place to start is really if you could give us some history on, 3D Sim and then the Ansys Additive product, kind of from how did you come up with the idea and where did this company start and all that stuff?
Yeah, sure. Well, the journey actually started 27 years ago when I got into the metal additive manufacturing research community in academia as a PhD student. So I started out doing research and developing some materials and metal and ceramic composites for additive manufacturing years ago, and then went on to have an academic career at University of Rhode Island and Utah State University, with some trips to sabbaticals to Finland, and then ending up at University of Louisville as my last location in my academic kind of journey. And throughout that journey within academia, we had spent almost 2 decades trying to understand the relationship between process parameters and microstructure and performance characteristics of all these different alloys. And how do you design a better process? How do you design a better material? Once you have that process and material combination, what are the properties, and how can you create parts that would be qualifiable with some sort of scheme using additive manufacturing? And after years and years of experiments, decided, well, there's got to be something more efficient than taking an entire PhD project to prove that you can use a particular material on one machine. And this sort of also came to the head. If you think about in additive manufacturing, this GE fuel nozzle was a huge deal where people talked about that a lot. And based upon my understanding of the time and cost it took, it was tens of millions of dollars of development to produce a qualifiable process for that one geometry. And again, most companies can't afford to spend tens of millions of dollars to qualify a single geometry for production, right? Now, in that case, it's going to save billions of dollars.
Right.
So it's worth it. But there's very few parts like that. So that's kind of the history and the background. And so somewhere around 2010, I started to work with Dipankar Pal, who ended up being a co-founder of 3D-Sim. And we started to think about, what if we applied simulation to some of these problems that we were trying to solve experimentally? And between 2010 and about 2014, we had several $1 million of funded research on developing new algorithms to predict the type of phenomena that we had been experimentally playing with. And in 2014, we thought, oh, we've got enough success that we should start a company and try to get this commercialized. And so, we talked to some people who had been around in the industry a long time, who had been very successful entrepreneurs in additive manufacturing and had been friends of mine because I'd known them for 2 decades. And they said, yeah, we're in, we'll help fund this startup. And so we went out and hired some great people and pulled, and in the end founded it with myself and Dipankar Pal and Nachiket Patil, and went out and started 3D-Sim. And for the first year, we were the co-founders were all still kind of straddling the fence between academia and entrepreneurship. But in 2015, we decided we needed to be all in order to make this successful. So we moved the company actually from Louisville to Kentucky to Park City, Utah, so that we could be close to this great software talent in the Salt Lake City metropolitan area. And then a couple of years later decided, hey, we can't really compete against these huge simulation companies very well in the global marketplace. We really needed to join one of them rather than compete with all of them. And through a process of winnowing down who would be the best partner, Ansys emerged and put an offer on the table that ended up being a really good offer for us then to merge 3D-Sim technology with Ansys technology in the additive arena. And we closed that in November 2017. And then the rest of it has been through Ansys. So that's kind of the quick, I guess, almost 3-decade journey here in a couple minutes.
Your overnight success. Yes. Yeah, that's the way it always is, right? That's fantastic. I didn't realize that it had started that long ago. That's fantastic. So that brings me to my next question, which is for our listeners to hear from the person that knows best probably at Ansys. Can you give us kind of a high level overview of the product suite? Because it's not just one product, right? It's multiple tools for additive manufacturing.
Yeah, happy to do that. when you think about what do you need help from software, and particularly physics-based predictive simulation software for an additive manufacturing, there's a number of areas, and we're trying to bring all these areas together into a unified suite. So one of the areas you need is, how do I just design the geometry in the first place?
Right.
And there's a lot of tools like topology optimization and lattice optimization, and then you might want to do really quick types of what if scenarios. So we're merging all of that type of design functionality into the Discovery product line and releasing that in this upcoming year. So customers can get sort of previews of that this coming year, and that should be fully released within a year from now. But right now, those sit in a combination of tools between, say, Workbench and SpaceClaim and some other tools. And again, we're merging all of those design-centric tools into the Discovery platform over the next 12 months. So then if you think, now that I've designed the component, now how do I set up a machine to build it properly? You've got to choose the orientation, and where do I put supports, and what are the process parameters? So we have software tools that are to help you with that orientation. And today that's known as our additive prep product to do the orientation and supports. And then additive print and Workbench additive also then allows you to simulate that orientation and supports to look at distortion and how do I compensate for distortion. And again, all of those functions are also being put into the same Discovery environment over the next 12 months. And then you have another area, which is, what about the microstructure and porosity, and how do I get just the right process parameters? And we have a whole bunch of tools in a product that we call Additive Science to look at, how do I optimize that process parameter set to get the right density and microstructure? So again, Additive Science is not going in the next 12 months. That's more probably 18 months from now before it'll be fully integrated into the Discovery platform. But as you can hear from this kind of quick overview, we want to take all of this additive related expertise that exists in about 3 or 4 different interfaces today within the Ansys portfolio, merge them all into one interface so that everyone can work seamlessly from designing to setting up the build to predicting process parameters to predicting microstructure, all in the same workflow.
That's fantastic. I love it. It's come a long way. It's pretty amazing. We use it at PADT. We recently, we've had that small machine, the Concept Laser M4, for quite some time, but we just got a larger EOS machine beginning of the year, and it's been really great to pull out those Ansys tools and use it on that machine. It's been, we've been along the journey as a user, and they just keep getting better and better at every release. It's been a really powerful tool for us. And speaking of using it, is there a user story out there that you can share? Because there's some great stories, but the customers always say, well, you can't tell anybody. But is there anything you can share that's kind of a user story that excites you, that people are using Ansys additive?
Sure. I mean, there's so many stories, but as you said, there's a lot of them don't let us share those stories. I think some of my top users right now that I get most excited about interacting with, because they will allow us to talk about it, are probably Siemens Energy and Baker Hughes and maybe some universities. But let me just briefly talk about each of those. Right. Siemens Energy, they're involved in a lot of power generation components. These are not aerospace engines, but they're power generation engines, which have similar designs. And they're finding that they use the entire suite or portfolio. So they'll do topology and lattice optimization to really zero in on these really lightweight designs for blades and assemblies and channels that you need to move fluid through. So they'll use Fluent, they'll use Ansys Mechanical to do the fluids and heat. They'll use our additive topo and latticing tools to optimize the geometry. They then use our additive prep to orient and create supports for it. They use additive print to do all the distortion compensation. And basically, they're using the end-to-end product portfolio just like we envisioned it. And it's
Fantastic.
really fun to see them presenting all of these case studies. And so they presented at ASME conferences and other conferences. But it's been a great. I don't know. It's really neat to see one customer taking the whole chain and doing what we had envisioned, almost a decade ago, was the potential for simulation
Right.
and that.
That's always satisfying when that vision gets realized and they get real value out of it. I'll also point out to our listeners that the name of the company is Siemens, which that's a competitive product as well, and they use the Ansys suite quite heavily. So we're very proud of that.
Yeah, absolutely. And I think another customer that's been really a great engagement, and we've also publicly talked about this partnership, is with Baker Hughes.
Mm-hmm.
And again, this is in the oil and gas and energy sector. It just happens to be that both of these are energy related. But in the Baker Hughes engagement, we're looking more at oil exploration and
Mm-hmm.
changing designs for low volume production of these oil and gas fixtures and rigs, and then emergency repair services, where you really quickly have to get something back out to the field because you can lose millions of dollars a day when a drilling rig or a pumping rig of some kind goes down. And so using simulation in the loop and using additive prep and additive print and those types of tools allow you to more quickly respond to these emergency situations. But where it's been surprisingly successful with Baker Hughes, surprisingly because the product was really early, was in their use of additive science. Just as we were putting our additive science tools out in beta, Baker Hughes went all in on how do we optimize the process to get the greatest productivity out of our machines while achieving our density and microstructure metrics. And an early success was they were working on a whole new, they wanted to use a different layer thickness in their machine than all the defaults that they had.
Okay.
And to develop a new layer thickness typically takes months and thousands of coupons to find the sweet spot for power and speed and all of the laser settings that you need for a new layer thickness. And they've done this for a number of other materials and knew they were in for a long slog to do it on this material. And they said, well, let's give additive science a try. And they then simulated thousands of different combinations. They tried to identify about a dozen of them that they thought would work based upon simulation, but were then hoping to then use experiments to down select from there. And when they ran the experiments, they found that every single one of the combinations that were targeted as successful using the simulation-based optimization, they all met their criteria.
Great.
And so not only did they come up with one, they've come up with about a dozen combinations that would work. Well, in that case, you can just select the one that makes you the most money, right? Mm-hmm. So that's an easy choice. But that was a really early validation from the field of this additive science product, which we've been working on for quite a while. Mm-hmm. That it really brings the value we were hoping to bring, taking months and thousands of machine and man hours down to weeks and very little machine and man hours involved in that. And so that's been a really, I think, our most exciting publicly discussable additive science early win.
Good. I'm very excited about additive science and have been since you guys first started working on it. And I think it's difficult to understate how much of a savings it's going to be when people start using it, because of the thousands of coupons, and the amount of testing that one has to do. It's just so expensive, and being able to do it in a virtual environment is going to be a game changer. So that's really, really cool. So I guess my next question really is, and you kind of talked about this, the integration into the Discovery platform and bringing more of additive science online. What's next for Ansys Additive that you can talk about?
Yeah, so in addition to bringing all of these interfaces together into a unified environment, we're also expanding the types of processes that we're simulating. So we're coming out this year with some new capabilities for directed energy deposition. So I should back up and say that the current portfolio is really focused on the sweet spot of laser powder bed fusion. So that's where you take a laser and you scan the surface of a bed of powder to melt it. And so that's the main process being used by most of our big customers to produce metal parts. But there's a number of them who also want to deposit metal as it's being melted. And so you can either use a wire plus a laser, or a wire plus electron beam, or powder plus laser. There's lots of ways that you can kind of put down material at the same time you're melting it, like an automated welding machine kind of process. And so we've started to add a lot more functionality for DED, which is the shortened version of that the acronym for that category of additive manufacturing technologies. And so we're putting out some new ACT extensions here in the next couple months, actually focused on DED, to allow us to really improve the simulation there. We have some beta and alpha work going on in binder jetting. So in binder jetting, you lay down powder and then you print a binder on that, and then you take that part that you make and you put it in an oven to bake it and sinter it. And during that oven process, there's a lot of shape change that occurs. And that's really what the difficulty in the process is understanding and compensating for that shape change in the oven. So that's where we're focusing all of our simulation tools there. Some of those will be out this month for early access for people who are workbench mechanical experts. And once we really nail that with our consortium of what's the best model to use and how do we set up it and compensate using this, then we'll add that into the more simple interface. But right now it's more set up for people who are workbench mechanical users. And there's also a functionality, I think less people are aware of what we're doing here, but there's composite simulation is really important for people who are doing like big layups of using these big polymer extrusion machines, particularly if they got fiber reinforced extrusion machines they're using with additive manufacturing. And we have a file format that it's called HDF5, which is a standard format out there in the industry. And we've begun to read in you can use this for composite layup, traditional composite layup, but you can also use it for 3D printed extruded composite layups and predict the properties of the part based upon the deposition path that you use to build it. And so we've got one manufacturer that's already, creating these HDF5, and we want to work with quite a few more of these extrusion manufacturers and get them to adopt this HDF5 output format. Because if they just convert their G code into HDF5 and add a little bit of material property data there, we can then read that in and predict the properties. And so then you could say, what if I change the deposition path? What would be the new properties of my component? And so that's already out there. It's not well utilized yet because we haven't really gotten enough companies to start adopting that HDF5 format. But we want to continue to do that this year, see if we can sign up some more companies and really help move the bar on adoption of these composite extrusion 3D printing machines.
Yeah, it's very exciting. We do that with our Stratasys machines, and we're really looking forward to that being supported. And back to the binder jetting, we're huge fans of binder jetting metal as a replacement for laser powder bed because of the speed and the volume that you can make. And the problem is sintering. That's making the green part great, but now I got to sinter it, and I'm very excited to hear that you guys are working on that because, we broke a lot of parts trying to figure that out. It's a very iterative process to get that sintering to work, and being able to do that virtually, just as with the powder bed, is going to be, I think, an even bigger advantage, and maybe the enabling technology to get these production powder bed system, the binder jetting systems to reach their full potential that the market has seen in them. I don't know that they've gotten as far as we had hoped by now.
It's interesting because I started in my work in 1993 in binder. Held together green parts and then furnace centering them, and spent years working in that area, and really we walked away from it in the late 90s because of this problem with sintering, because we couldn't really understand. If you just put in a new geometry, we had no idea what was going to happen to it in the oven, and simulation tools were just not there at the time.
Right.
And so it was always a trial and error based iterative, zeroing in on the right design to get it to shrink and distort to the correct shape. And I really think we're moving away from that really quickly. The predictive centering is already seeing a lot of benefits for a lot of geometry types. Good. And I think it's really just a matter of, a couple more years of really fine tuning this. And I think binder jetting can really take off.
Right.
Like you said, it's kind of taken off because of the potential for it. People are investing not in what it can do, but what they hope it will do in the future. And without simulation, it's really never going to get there. But I'm quite confident that we're going to give people what they need through simulation because of the early success we've already seen in our consortium and in our experiments.
Good. Excellent. Very excited to hear that. And my partner rates you quite well, and I've worked with him for decades. He's got space set aside for when this gets figured out for a big one, big metal and ceramic, hopefully. Yep. So that I really that's all the questions I have. That I always like to kind of finish up with. We have people listening to the podcast that may not be as familiar with the products. Is there anything you want them to know about Ansys Additive that maybe the general user community isn't aware of?
There's a couple things that maybe the general user community is not really aware of, and that's the link of Ansys Additive with a couple of our other product lines, where you can really get some good synergy in an organization. One of those is with our Granta Additive initiative. So Granta is our materials database, our materials management system, where you can track all of the experiments and simulations you've been doing so that you can come up with the right assumptions for your material models for all of your simulations, as well as just for design allowables and things like that. So Granta is this amazing tool that lets you store and track. In the area of additive manufacturing, you can store and track all of your, powder recycling and all of your linkages between, raw material, process parameters, experimental results, simulations we've done from that, and heat treatment, all of these things that just really are difficult to manage when you're qualifying additive. Now, this Granta Additive piece, combined with our simulation tools, really is helping people accelerate their qualification schemes. So if you can keep all this data together and organized well, then certifying a new geometry becomes much easier and much cheaper. And so that's one area that I think people should look into if they're in an industry where they have a stringent certification and qualification criteria. I think Granta Additive is going to save them a boatload of money and time. The other thing I think has been really interesting is a couple of things I've seen our ACE engineers do in the area of digital twins and additive. And we've seen some early success by using some of our tools for digital twin combined with maybe some traditional simulation, like a fluent simulation for looking at flow, and then combined with the additive simulations to really zero in on the correct designs, and then even on how is this part going to perform, and how do we monitor and control this system as it's being put into operation. And that's an early area. We don't see a lot of customers yet using our additive tools in their digital twin side, but some of the early pieces I've seen, which I don't think we can talk about publicly, have been really successful. And so I think that's an up and coming area in this digital twin area that we'll find additive becoming stronger and stronger part of that initiative.
Cool. Yeah, the synergy that we're getting from some of these other acquisitions is pretty impressive. I'm always amazed at, it takes a little time, which is appropriate, but eventually when they get them all working together, boy, you can save so much time and money. It's really nice. Well, that's about all I got for today. I really appreciate your time. I learned a few things that I didn't know. So hopefully our listeners did the same. And I hope you enjoy the 2021. It's going to be, I think, a fantastic year for Ansys, and going to see even more great things happening. So I do appreciate your time.
Absolutely. Thank you for the opportunity to be here today.
Thank you. All right. Well, welcome back. It's great to get this information from a person that is in the middle of it all. We can't wait to get our hands on 2021 R1 and start using some of the new tools for ourselves, as well as to help our customers that use Ansys Additive get their hands on it as well. It just keeps getting better and better. If you want to learn more and you are one of PADT's customers, just go ahead and reach out to your salesperson or to the tech support team, and we'll be happy to set up a time to talk about what you can do with it. And we'll talk more about it. If you're not a PADT customer, just go to the Ansys website and go to Products, Structures, Ansys Additive Suite. And there's quite a bit of good information there, and lots of buttons to click to ask somebody to reach out and talk to you about it. So it's time for our commercial. And so new year, new commercial. I want to talk about our Ansys mentoring offering. Mentoring is one-on-one support where you get one or more PADT experts assigned to help you. You can use that for custom training, doing a simulation, then showing you how to do it yourself, helping solve a tough problem. Maybe it's getting support beyond what your maintenance support includes. As you plan your year out and get to the parts where you think you might need some extra help, reach out to us at support@padtinc.com. And Joe Woodward or Ted Harris, who've been on this podcast many times, will reach out and set up a time to learn more. It's really is an investment that the customers that use our mentoring say pays very well. It's not as good as investment as Bitcoin is right now, but Bitcoin will crash someday soon. What you get out of PADT's mentoring will last pretty much forever. So in the world of news, let's start with the Ansys stock. Taking a look back at 2020 and how Ansys stock did, there was a rally at the end of the year, and they did very well indeed. They finished the year at $373.85 a share, having started at $256. So that's $117. If you bought one share, you would have made $117 on it. That's $41 or 41.57% gain for the year. The S&P, that's his comparison, went up 15%. From the start to the end of the year. The other stocks we watched did even better. PTC, which is more of a PLM play, did 58%. Autodesk was up 62%, and Altair, which is the closest to Ansys, did 60.5% growth. But they were kind of struggling last year, so I think they had a lot of room to go up, whereas Ansys went from great to greater, right? Ansys did hit an all-time high for 2020, actually for everything before 2020 as well. Just before Christmas, I think on the 24th, they were at $364 a share, and that was what I was going to say was the high, but then let me check, because when I was writing all this down, they had set a new high. Let's see where it closed, at 374. So they did. They set a new all-time high for Ansys stock at $374 a share. So a little bit better than the peak before. So during the day, they were at 375.78 was the all-time high that they hit earlier today. So off to a good start for 2021 for Ansys stock. We'll see how it goes from there. Good stuff going on. And in other Ansys news, there's really nothing. They didn't have anything that they announced. One thing that did come out that's worth sharing is that they did release the results. They announced the results of the 2020 what is it called? Art of Simulation competition. You can check it out at www.ansys.com/other/art-of-simulation, or you can search for Ansys Art of Simulation and find it that way. This is more than eye candy, though it is really nice eye candy in all the different physics that Ansys supports. These are real-world complex problems solved well. There's a brake, there's an engine block, there's blood vessels, and even a CFD simulation of someone's apartment. So do check that out, take a look, and see how that goes. No news from PADT to share with you for the beginning of the year. Let's talk about blogs. So just like us, it seems like at the end of the year, they published a bunch of blog articles. I'll talk about ours in a second. For the Ansys blog, they had quite a few. I picked 3 like I usually do, but there's more there. So do go to ansys.com/blog to learn more and see what other articles might interest you. May not be the same thing I'm interested in. The first one I picked was called A Better Way to Generate and Deliver X-Rays, and it looks at how to combine accelerators, so like particle accelerators, and lasers to create high-energy X-ray beams. It's bleeding-edge stuff, has a lot of medical applications, so a really powerful small beam, and it's from an Ansys startup company called Lumitron Technologies. So do check that out. It's pretty interesting. It's got some Fluent in there. It's got some HFSS. Neat stuff. Then the second one was called Solving Composite Design Challenges with Engineering Simulation. And it basically does what the title says. It goes over the Ansys composite offerings. So if you haven't looked at Ansys composites, the Ansys Composite Prep and Post Process, or ACP we call it, do take a look at this article. It's a good high-level overview. And then it goes on to talk about one of the probably the best features in the composite tool is now they support the HD5F or F5 format, HD F5. I always want to switch those two. And that's a file format that all of the composite layup tools support for manufacturing to say, here's the different layers, here's how things are oriented, here's how the fibers are oriented. And if you listen to the interview on this podcast, you'll know that even the Ansys additive folks are using it for composite as well. So that allows you to take layups from Aniform, Cadwine, 9T Labs, and Hexagon and import those into Ansys for simulation. So big time saver there. And the last one is called Repairing Bone Loss with Simulation-Generated Patient-Specific Implants. I chose it because it combines some of my favorite things, simulation, 3D printing, and medical. It's a great example of how using virtual tools to design custom solutions is only enabled through Ansys and 3D printing combined. So basically what they do is they take a CT scan of, say, someone's jaw that has had cancer and they had to remove the bone, and then they design. In the past, they would use CAD tools to just kind of stick a piece of metal in there. Now they use Ansys and some of our optimization capabilities in the additive suite to not just put in a piece of metal, but to optimize the shape of that metal so that it has the same stiffness as the other side of the jaw, right? So you can imagine you don't want to have one side stiffer than the other. So, and also survive and fatigue and all those things. So do check that out. It's a really fascinating article. Great use of all the technologies of simulation and 3D printing. On our blog, we did the same thing. We all kind of realized we needed to write some articles, so we got them out there. The first one that I want to mention is also about 3D printing and simulation and biological, but it's bio-inspired rather than medical. We shared 3 academic papers that PADT contributed to on simulating bio-inspired geometries. So PADT's Alex Grishin, who's been on the podcast before, did most of the work here, along with our partner ASU. This is we've talked about in the past, we have a NASA STTR that we have with ASU that is looking at how to take, organic structures and use them in engineering, and really focusing on honeycombs initially. So these papers are all about understanding honeycomb structures in additive manufacturing. And there are 3 different papers that look at different aspects of simulating and testing these honeycomb structures, both natural as well as 3D printed. Then the next one is our very own Josh Stout added a post called Using Ansys Ice Pack Results in Ansys Mechanical. So if you're doing electrical cooling and you want to take your thermal loads from your electrical cooling simulation in Ice Pack and put them into mechanical, he gives a detailed step-by-step instructions on how to take different kinds of loads. And there's several different approaches, like always with Ansys, and get them into mechanical. It's very useful. And he's even included an example Python script for one of the methodologies that he likes to do that solves a little bit of a problem that he ran into. So good stuff. Check that out. And last is I actually had time to write 6 articles. It's 6 posts that I did on how to get better quality output from Ansys Mechanical. When we look at the statistics on our blog, every month, one of the top 10 articles is making pretty plots in Ansys Mechanical and Ansys APDL. And we haven't updated that in quite some time. I think it's about 3 or 4 years old. So I started I was doing some marketing, making pretty pictures for marketing, and decided, hey, I should probably, while I'm doing this, use that as an opportunity to update, making plots. I should use it as an opportunity to update what's available in Mechanical now. And that turned into a whole series. So we start with that, how to make high resolution images with transparent backgrounds. Then we talk about how to make really, really high quality images using Ansys Insight, which is a high-end post-processor that Ansys has, and basically rendered images. Then we talk about videos, different options for making videos. Then my favorite is how to make animated GIFs that are high quality, and you can get some really nice looking ones. Then we talk about 3D plots on web page. I don't know if you know this, but there's a file format called X3D that's also a standard that allows you to embed 3D results, contour plots into, as well as CAD files if you want to, into a web page and view them. It uses JavaScript. The article goes into the details. And then last but not least, and some of you may have seen this in some of our, on LinkedIn, I've talked about it quite a bit, is how to make a physical printout on a 3D printer. So we have a color 3D printer, a J55 from Stratasys. And I figured, while I'm here, let's figure out how to print this thing. So I did. And it's pretty cool. Do check that out. All of those are there. So I think everybody should take a look at how to make, if you're a mechanical user, how to make the high resolution images, and the rest of it if you need it. So hopefully you enjoy those 3 blog posts that we did at the end of the year. Upcoming events. We've got, let's see, if you're in Arizona, on the 14th of January, we've got our first tech business networking event. It's the 10th one we've done since COVID started, and that's from 5 to 6:30 on Wednesday the 14th. Then we've got a webinar, Optimize Additive Topology with FDM Fixture Generator. So this is for both Ansys and Stratasys people. So it's basically how to create fixtures for FDM printing using topology optimization. And that one is on the 21st. And then on the 22nd, we have a panel discussion on the present and future of optimizing topology for manufacturing. Well, we'll sit down with some folks from Ansys as well as Topology and PADT and talk about basically using topology optimization for manufacturing. Right? We usually talk about it for the end part itself, but what about using it in manufacturing? So really interesting topic, especially for those of you that are listening about additive manufacturing. The only Ansys event I want to share with you is it's time to start thinking about Ansys Simulation World. That was our first global user conference that was online last year, and it was such a success that they're doing it again this year. It's April 20th through the 21st. You can find out more about it by going to simulationworld.com. That's one word, simulationworld.com. And they're looking for presentations now. So if you've got something you want to share with the greater Ansys user community, check out the forum there and submit. It was a great event last year. I really enjoyed it, learned a ton, got to virtually meet a couple of people, and I hope it'll be a little bit even better this year now that we've, that was put together very quickly because, COVID, we had to cancel all the user group meetings. So I'm hoping this one will go as well or better. So look forward to seeing some of you people there. So I want to thank everybody. That's pretty much it. All I got for the day. Don't forget to subscribe at www.padtinc.com/opt-in, and that's to subscribe to our newsletter. Spread the word. Be safe. Even a mild case of this virus really sucks. I'm just finally getting over the brain fog, which was really weird. And if you get really sick, it's you've all seen the stats. It's not fun. So do be safe out there. It's widespread and it's simple math, and it's hard to avoid right now. So on that positive note, don't hesitate to reach out, and we hope to talk to some of you soon. Thank you for joining us for the All Things Ansys podcast, episode 79. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of the current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.